Wonderful assistance? Okay.
Okay, perfect. So, hello everyone. My name is Anna from the OTH in Regensburg in Germany. And today I want to tell you something about our paper about optimizing linear construction processes. As you have heard before, linear construction can mean a lot of things like railroads, roadworks, but we focus on one specific topic, which you have been also heard before, energy transmission lines. So energy transmission lines in Germany, we have proposed, the government have proposed 35 projects to transport the electricity, and this are totaling 14,000 kilometers. From this 14,000 kilometers, right now only 4,000 kilometers have been built. Since 2013, we want to build the other 10,000 by 2030. So there is a need to speed the processes. And so the research question we ask in our paper is if an AI-based simulation framework can generate and optimize the execution plans for this kind of project, considering the lack of real-world historical data. So I will just explain to you how it normally works. Normally you have like a cost estimation and scheduling at the start of the project. Then you come to the execution phase. There you have an execution schedule. Then, as all of us know, in construction site there are often claims or change orders, or the site conditions are not what we expected. So we have the need to get a new execution schedule. This new execution schedule is often a reaction on current conditions and current constraints and doesn't consider like the future or how this changes will have an impact on further project activities. So you have new changes, new claims, and new conditions which you didn't consider, and this like so you have like a chain of new execution schedules and new blindside reactions and new consequences which you need to consider. Our workflow, we propose that if changes appear, we have an AI-based parameter space reduction, like we are looking like what are the optimized parameters. We have a simulation of the promising variants, like for the whole project and not only the one construction site. We have the validation by the construction workers, and after that we have a new execution schedule which considers consequences which will appear in the future. So how did we do this? We proposed the following workflow, like you have an input space for your objectives, like the budget, the cost limits, and how the project needs to be built. You can have the design space where you can further set some constraints, like we only have like a specific number of excavators which we can use. Based on this, there are parameters generated and these can be simulated. And this simulation gives us results about the construction time, a cost estimation, as well as the resource utilization. Then the results are evaluated against the targets, like is the cost low enough? If the KPIs are met, we have the human in the loop. So the construction worker or the construction worker looks at it and tells if the proposed variant is feasible, or if it's not like if it's not possible to do it like that in reality. And then we have the optimized evaluated variants. If the needs aren't met from the beginning, the loop is started again. And this is like the optimization loop. And as you can see, it is heavily based on the simulation. And this is what I mainly want to propose. So you can see a video of the simulation here. It's an open cut trenching. And we have like 5 processes. It's the topsoil removal, then the excavation of the trench, the pipe zone construction, which you can see in the simulation, and the backfilling, as well as the topsoil replacement. So this is a parametric simulation, and the parameters which go into it, you have also heard from Mike before, is, for example, the cross-section, the routing, the soil conditions, as well as the topography. These are parameters we can't change, like they are set simply by the construction site conditions. Parameters which we can change are, for example, the vehicle count, the cycle time, as well as the storage distance. And we, to verify the simulation, we varied these parameters and got some simulation runs to verify if the simulation can predict the real world close enough, because as I mentioned before, we lack real life data. So I ran some simulations and then did the correlation matrix to decide or to have a look if the simulation can depict the reality. And as you can see, like if the vehicle count goes up, total duration is lower, but the transport idle time rises. As well, like, so the main takeaway point from this is the vehicle count speeds the limit duration, but only like for a certain point. Like there's a threshold, and after this threshold, there's not that big of an impact anymore. You can also see that the cycle time has a really low impact, which can be neglected, which is good for us in the reality, because this is one of the parameters which is really hard to control. So we discussed this with experts, with construction experts on the site, and they told us, yeah, like, yes, these are the observations we also made, like in real life, and so this is how we verified this. We are working currently to verify it with real life data, but we don't have it like in a structured way yet. So we can look at what is the simulation saying, how long does the process take, and what is it in reality. So what really did we contribute with this paper? The contribution is the proposal of this AI integrated simulation framework, just to have like generate variants, evaluate it, and have some decision support. We validated the simulation model, and with the simulation model we are also providing a foundation for synthetic training data, because for the, I told you about the AI, and for the parameter space reduction, we are training machine learning models. And this is a little outlook from what I'm currently working on. This is not in the paper anymore. But I have been training it to see if the machine learning models can are like the same like the simulation, like not with the reality. And I have some deviations still, as you can see, but these are like my first results. And this is to we have like an influence of the amount of data we have right now, because the training data is still in process, and this is the correlation we made, like a little outlook, like what I'm currently working on. And this was my presentation, and I'm open for questions.